Hello and welcome to ThePrint. I am Mohana Basu, Assistant Editor at ThePrint. And today we are going to talk about the quantum mission that was announced by the cabinet just yesterday, on Wednesday this week. And what exactly this mission is, what it encompasses, and what we can expect from it in the future. That's what we are here to discuss today. And with me, I have Dr. Akhilesh Gupta, and he is the Senior Advisor at the Department of Science and Technology, and he is the one heading this mission. And he is going to tell us exactly what it is. What is quantum? This is something that, a lot of people are struggling to really understand. When we say quantum computing, what are we talking about? What is quantum?
Well, if you ask me what is quantum, I think if you heard that the classical mechanics and the quantum mechanics, the difference has been that, if you recall a very famous de Broglie theorem, it says that every particle, whether small or big, has a dual character. One is the particle, and another character is the wave.
Right.
But anything, in fact, all of us generate wave.
Right.
But larger the size of the particle, smaller is the wave. At the quantum level, the size of the an atom is nearly 300 crore less smaller than the human being. So at that level, the wave size is larger than the particle size.
Right.
That is all quantum mechanism, where it shows that any particle, and just give you a very good example of quantum, is the light. When the light is coming to you, you think that it is, what do you think? I mean, your reaction is that it is an electromagnetic wave.
Right.
It is an electromagnetic wave, but then this light is full of photons,
Yes.
particles.
So it capitalizes on the dual nature.
Duality of the particle and the wave nature.
Right. Right. So where and how does this fall into with when we talk about computing? What is the difference that we see when we are talking about classical computing versus quantum computing?
So again, let me go to the basic. So when the computers were discovered, and that include even your mobile. Mobile is also a computer. Your calculator. This was the first computer in fact. So the discovery of this computer were based on the binary digits, bits,
Right.
0 and 1. So all digits were in the combination of 0 and 1. I'll just give example. If it is, you have to write 1. So in the 4 digits, you write 0, 0, 0, 1.
Right.
If you write 2, 0, 0, 1, 1, and so on. So every computer cannot recognize digits, 20, 25, and all these digits. It recognizes bits.
Right.
So the bits are being used for all computations.
So that is what we
That is
know.
what is the conventional computers only.
Right.
But when it comes to quantum bits, it is the superposition of 0 and 1. That means, if suppose there is a 0 and a 1, you have crores of stages or states between 0 and 1.
Right.
Which means that there is a superposition taking place between the 0 state and the 1 state.
Right.
In the physical space, let me tell you what is 0 and 1 space. So in the atom, you have one orbit, and then another orbit, and then another orbit. When the electron moves from one orbit to another orbit, it leaves some energy.
Right.
That energy is the photonic energy,
Right.
photon, and that also has the wave energy. So it is that energy that is actually represented in the case of quantum.
Right.
So in quantum, instead of bits, it is qubits.
Yes.
That means quantum bits, where the energy between one state and another state is being represented through superposition of those two states.
Right.
So that is why it has much more versatile, much more you can say in a very it has so much of representation part that you can have computing which can not just depend on 0 and 1 but also numbers between them.
Right, right. So, in that sense that when we talk about bits, we are limited to two positions, that is like 1 and 0. But when we go to quantum, those possibilities increase exponentially.
Right.
And that's where we have the possibility of like one input giving multiple outcomes. And when we come to computing, just for our audiences, I would like to just give this analogy that I came across when we were reading or trying to write about this new, field. If a normal computer is trying to look for a phone number within a directory, it will go, entry by entry. It will look at one page at a time, one entry at a time. But a quantum computer can do that simultaneously, which is where the speed factors in. And which is why we are, chasing after this technology right now. Now, let me we have to be very clear that at this stage, a quantum computer is still not something that has been viable. We don't really have anything in our hand. So what is it that, where are we in this field of research right now? India, what is the kind of achievements we have? What are the kind of milestones we have already achieved? And what are the institutes working on at this point?
So, any technology product that you see in the market, let's say your mobile. Do you think that mobile has been developed just in one stroke? Mobile has been developed in several stages. The first stage is called the research. Research then goes to technology development, then prototype development, then testing and validation, and then only product comes to the market. In the quantum, entire world, not just India, entire world is in the state of technology development, which means that R&D has been done and now we know what is quantum, but now we are trying to develop a project which is quantum computer.
Right.
We are yet to reach a state where we can say this is marketable.
Right.
We are in the state just prior to the market, which means that we have done all R&D work, we have done technology development, we also have done prototype, but we are yet to come to the market in some sense. So there is not a single computer in the world, quantum computer, which you call it operational.
Right.
Now this is the advantage that India will have. In none of the previous cases of any mission where India has launched a mission or technology mission where technology is yet to get matured in the world. It is like we have always been borrowing just like in
we've always been playing catch up to other countries.
Catch up.
Yeah.
So the reaction and not, so it is always we have been reacting to what has been developed.
Mm-hmm.
We've never been proactive in that.
Right.
This is the proactive mission.
Right. Right. So, coming to the applications, I understand that right now we don't have an operational computer. But what are the expected applications of this technology that current computers are not able to fulfill? So,
this is a transformative technology. It's a technology shift. I will give you example of technology shift. See, I don't know, you were not gone at that time, but I have seen in my childhood, we used to have a radio which was wall based. So there used to be wall in the radio. Mm-hmm. And whenever you tune to any station, it will come the voice used to be very very unmodulated voice used to be heard. Right. Then suddenly came the new technology of transistor, mm-hmm. solid state. Wall to solid state was a big technology shift. India got it much later than the world, but we adopted.
Right.
This is technology shift.
Right.
So this and so it is earlier is better. The world is catching up with this technology. There are only 6 countries or 7 countries which have this technology developed, not operational. India is now catching up, and we will also in next 8 years develop and make it mature, so that it now the applications are diverse.
Right.
You have the application in agriculture, water, health, environment, every area. I'll give you some examples. The health is the biggest, going to be biggest beneficiary of this mission. So all the sensors that you have for health, see, anybody got brain stroke or heart attack or anything. See, detection of all this will take time. All kind of, like, example is, suppose somebody get epilepsy. It's a minor epilepsy is the smallest bug in the brain. The detection is very, very difficult. And if somebody who gets epilepsy today and goes after 3 days, it is not traceable also. The mission, the sensors that we are going to use here, these are called quantum sensors.
Right.
They will be able to detect the smallest bug in the brain and in no time.
Right.
So this is one application. The other application is the defense application. All the defense intelligence is based on 2 things. How much you can crack the messages of other countries or the enemy countries, and how much messages that you send are secured.
Right.
The quantum technology or quantum communication technology will be able to create a nearly impossible cracking of any message. It will be impossible by any hacker to crack. So this is so you will be able to secure. Third application, which is very important, is the digital transaction, that money that we have. All of us have money in the bank, and we do every day digital transaction without even knowing how much is that secure. This will give you a most secure. That today banks might claim that your money is secure, but you tell me the 4-digit that OTP that you receive.
Right.
How do you trust that OTP is secured? This quantum communication will give you secured, ensure that all money is safe and all. And like that in agriculture, in environment, in everyday life, you are going to have application of quantum technology.
Right. So security is actually one of the the 2 things apart from the speed that speed of computing. Security is one of the major advantages of quantum computing, and this is also like the very basis of what quantum computing is based on. That a particle can have the probability, like we just assume, the best way to explain it is we assume that the particle is in 2 places at the same time, 2 positions or 2 states at the same time. So, in physics we've learned this, that if we try to actually measure where it is, then the whole system sort of falls apart. Then that quantum nature of it just falls apart, and that's what's going to happen. So that is what makes the whole system very secure. But that brings us to the strategic, applications of this, which is again, I believe, the reason that government really wants to get a head on with this, because we want to be ahead in the game. If we have other countries developing this technology before us, then our systems are sort of left vulnerable. So, tell us more about that. Where, what exactly is the plan that way?
So, so therefore this, let me tell you, India is ready for going forward with this technology development and the commercialization. It will take some time for commercialization, or they are ready with it. So let me give you a kind of plan that we are thinking of. So there will be, we will set up 4 technology hubs in 4 areas, that is computing, communication, sensing, and the materials. So the idea is that let group of scientists work in this area. We are also starting Section 8 companies in these hubs, so that we should not wait for technology to be market in future, but rather that we start the things at the earliest.
Right. So simultaneously.
So what we are doing, development will be going, and concurrently we will develop the prototype and beyond.
So what are the 4 hubs?
So these 4 are, I mentioned, the one hub will be, so you mean we haven't identified individual, but some broad ideas we have already done, that which are the institutions have identified, but we will go very democratically and we'll advertise, call for proposals.
Right.
So that these hubs can apply, but they need to come in consortia.
Right.
So they all need to come in consortium, and then
so that there is like a collaborative work and not scientists working in their silos and their labs.
So I'll tell you, there are nearly 80 scientists are working in the country in this area. 40 institutions are there. So we will there should be so it is a kind of work that we don't want that should be done in silos.
Right.
We want the scientists to collaborate and work in tandem with each other as team rather than working in silos.
Right. Now, coming to the figure that was quoted at yesterday's briefing, 6,003 crores. So how is it that this is going to be utilized? Like, is it, again, like for the audiences, we already had a program from DST that funds research in this area called Quest. So how much of this is going to the universities for particular projects, and how much of this is for, like infrastructure development?
So there are 4 components that we are going to focus on for this technology development. So each of these hubs, those 4 hubs, will be given money to the tune of, I'm just giving goal fund figures and thing, to the tune of something like 800 to 900 crore, each of them. And this money will be utilized for undertaking technology development, human resource development, international collaboration, and also for other work. Inside, there are some other things that so each of them will use the maximum money will be spent for technology development.
Right.
And for that, whatever infrastructure development is required, like equipments are required or anything, that also will be purchased out of that. But then beyond that, so we are also, this is the hub work, but we are going to go up beyond the hub. So there will be market, each of the hub also will have a Section 8 company, but then how do we connect with the industry? So there is going to be a mission coordination cell which will work in tandem with the mission secretariat or DST to create market, right, to create international collaboration apart from what the individual hubs are doing. Right. And then there is a monitoring committee chaired by PSA, Principal Scientific Advisor to Government of India, and then above that there is a mission governing board chaired by some eminent scientists or industrialists. So the whole structure is that, and we work in 3 time scale. So first 3 years, then 3 to 5 years, and then 5 to 8 years. So the idea is, see, technology development might take some time. In the initial 3 years, teething trouble will come. We know there are challenges are going to come. Once 3 years have gone, then there will be some mid-stage development will take place. Actual maturity of this technology will take place at the in the end of the second stage, that is at the 5th year.
Right. So, in fact, there are like defined milestones that have been sort of, put out. We will link the story that we did just yesterday in the description below. But the end goal after 8 years is 1,000 qubit computer and communication between a ground station and a satellite at a distance of 2000 kilometers. So now this is where we are talking about another fundamental concept of quantum physics, that is entanglement, where how a particle changes its state sort of affects another particle that is so-called entangled, without them actually having any connection as such. So they are at different places, but a change here will cause a change there. In contrast to what we see in our classical physics, where there's a wave traveling through some sort of a medium. So that's where we sort of achieve the speed. So this is a very, very interesting avenue to sort of step in, and it's not like we are catching up or trying to do or getting in. We will become the hub. So final comments, closing comments. What is your expectations from this project? How excited are you to be heading this mission right now?
See, this is as I said, this is a technology transformation. There are very few occasions in the country when we have witnessed technology transformation. Technology adoption, technology transfer, we have seen many missions. So our excitement is like, government has given this opportunity to DST to be at the front, leading such a mission where the technology transformation taking place. Yeah. So I think as an entire DST team is very excited, and we can say that we will not leave a single stone unturned in making this mission a successful mission.
Right. I wish you all the very best, and we are also looking forward to the results that come in the next couple of years. And we at ThePrint will continue to follow this story, because there will be new breaks. There are already some institutions who have demonstrated the technology, and we hopefully will be able to bring you such stories regularly. Do keep following us on all social media platforms for the latest news updates. This is Mohana Basu, Assistant Editor at ThePrint, signing out.